Good morning, my colleagues. And we pick up here about the pricing of a bond, how it changes over time. And the important point is here's figure 6.1. And this is an interesting, it's the sawtooth characteristic of a bond price. You'll know as time goes on, you notice as time goes on, it approaches par, right? You can see it. In all cases, if it's at a premium, it approaches par, and then if it's at a discount, it'll approach par, and if it's at par, it'll stay at par, but it doesn't do so cleanly. It's got the sawtooth pattern, and that's due to the coupons. You'll notice here for the zero coupon bond, it's a nice even flow, and because there's no coupons, of course. So if the yield to maturity basically remains constant between coupon payments, the prices of all bonds rise at a rate equal to the yield to maturity as the remaining cash flows of the bond become closer. But as each coupon is paid, the price of the bond drops by the amount of the coupon. Okay? When the bond is trading at a premium, the price drops when a coupon is paid, will be larger than the price increase between coupons. So the bond's premium will tend to decline as time passes. So if the bond is trading at a discount, the price increase, right? If it's at a discount, here's the price increase between coupons will exceed the drop when a coupon is paid. So the bond's price will rise and its discount will decline as time passes. So ultimately, the prices of all bonds approach the bond's face value, as I mentioned here, when the bonds mature and their last coupon is paid. So you can see the effect here of the coupons getting paid here, right? Basically the coupon is paid, so the price goes down, but then basically it goes back up here. So just as for a bond as a premium, as each coupon is paid, the price of a bond drops. You see that right here, right? By the amount of the coupon, and when the price drops when a coupon is paid will be larger than the price increase between coupons, which is here, right? So the bond's premium will tend to decline as time passes. So you can see this coming down. All right, so I hope everyone's clear. So the graph illustrates the effects of the passage of time on bond prices. When the yield remains constant, the price of a zero coupon bond rises. And as I showed you here, it goes up smoothly, right? It goes up smoothly. Remember, zero coupon bonds don't pay coupons. Sorry about that. The price of a coupon bond also rises between coupon payments, but tumbles on the coupon date, reflecting the amount of the coupon payment. For each coupon bond, the gray line shows basically the trend of the bond price just after each coupon is paid. So you can see this trend here after each coupon is paid. Okay, this is what this gray line represents, and you can see the bottom is the coupons being paid. So basically, that's it for that. So let's whoops. All right, so interest rates in the economy fluctuate. The yields that investors demand to invest in bonds will also change. So let's now look at the effect of fluctuations in a yield to maturity. So here's a 30-year zero coupon bond. You can see there's a 30 there, and it's got a 5% yield to maturity. The bond will initially trade for $23.14. But suppose interest rates suddenly rise so that investors now demand 6%. So interest rates are going up, right? They will invest in if they invest in that bond at 6%, right? Here's the 6%. This change in yield implies that the bond price will fall to, so you can see interest rates have gone up, right? In this case, from here to here, so the bond price has gone down. All right, so as figure 6.1, let's going back to figure 6.1, that graph we looked at, the Sawtooth Graph. Bond prices fluctuate around the time of each coupon payment in a sawtooth pattern. The value of the coupon, as I mentioned, right? The value of the coupon. So let's look at that. The value of the coupon bond rises as the next coupon payment gets closer, and then drops after it has been paid. This fluctuation occurs even if there is no change in the bond's yield to maturity. Okay, so because bond traders are more concerned about changes in the bond's price that arise due to changes in the bond's yield, right? So the yield is going to really affect it, right? Remember, it's an inverse relation. Interest rates and bond prices are inversely related, okay? Rather than these predictable patterns around coupon payments, they often do not quote the price of a bond in terms of its actual cash price, which is also called the dirty price. So the actual cash price is called the dirty price. A bond's actual cash price also refers to as the invoice price, okay? So there's two names for that. Instead, bonds are often quoted in terms of a clean price. Now, what's the definition of a clean price? Which is the bond's cash price less an adjustment for accrued interest, the amount of the next coupon payment that has already accrued. Remember now, as time is going on, the interest is accruing, right, for the next coupon payment, and that's called the clean price. A bond's cash price less an adjustment for accrued interest, the amount of the next coupon that's already accruing. So that's accruing over time. All right, so that's accruing over time. So that's the cash price less an adjustment for an accrued interest. So remember, a bond is actually has an actual cash. It's an actual cash price called the dirty price or the invoice price. Okay, so we got to remember all these words. They're different words for prices on bonds. Come on. Okay. So let's just look at these words here. Okay. So the clean price is the cash dirty price minus the accrued interest. Remember, as you're holding the bond, the interest is building up, right? So the accrued interest is the coupon amount times the days since the last coupon was paid over the days in the current coupon period. All right, so here's a blow-up of that sawtooth curve, all right? So note that immediately before a coupon payment is made, the accrued interest will equal the full amount of the coupon, whereas immediately after the coupon payment is made, the accrued interest will be zero. Thus, accrued interest will rise and fall in a sawtooth pattern as each coupon payment passes. So this is an important concept that we looked at in the other graphs, and they're giving you a blow-up here of that, okay? So this is how the sawtooth pattern is coming about. So as figure 6.1 illustrated, the bond's cash price also has a sawtooth pattern. So if we subtract accrued interest from the bond's cash price and compute the clean price, the sawtooth pattern of the cash price is eliminated. Okay? Thus, absent changes in the bond's yield to maturity, its clean price converges smoothly over time to the bond's face value, as shown in the gray lines. So you can see this is being caused by the coupons accruing. Okay? That's what this is all about here. All right, so this is statement kind of like is basically letting you know why it's becoming a sawtooth, and it's the effect of the accrual of the coupons. All right. So basically, what this illustrates is a general phenomenon. So a higher yield to maturity implies a higher discount rate, right? So a higher yield to maturity is going to apply a higher discount rate for a bond's remaining cash flows, okay, reducing their present value and hence the bond's price. Therefore, as interest rates and bond yields rise, bond prices will fall and vice versa. So here's that important statement I was making. Real important. The inverse relation. As interest rates and bond yields rise, bond prices will fall and vice versa. All right, so this the sensitivity of a bond's price to changes in interest rates depends on the timing of its cash flows. It's discounted over a short period. The present value of a cash flow that will be received in the near future is less dramatically affected by interest rates than a cash flow in the distant future. Thus, shorter maturity zero coupon bonds are less sensitive to changes in interest rates than are long-term zero coupon bonds. Similarly, bonds with higher coupon rates, because they pay higher cash flows up front, are less sensitive to interest rate changes than otherwise identical bonds with lower coupon rates. So you can see how time and interest are affecting the bond's price. All right, now this is a real important statement. The sensitivity of a bond's price to changes in interest rates is measured by the bond's duration. Bonds with higher duration are highly sensitive to interest rate changes. Okay, so this is called, there's a couple terms here that refer to the bond's duration, and this is not maturity, and it's called Macaulay duration and modified duration. Okay, so these are important concepts here. So here's a nice example here that illustrates the sensitivity of bonds to their prices, and they do this for a zero coupon bond and a 10% annual coupon bond. Okay, so you should go over this, and you can see the changes in the sensitivity, what the effective changes. All right, I'll stop there, and we'll pick up at this video because it's getting long now.